All right, lesson 2.1, starting off chapter 2. We're going to be talking about vertex form and standard form of quadratic functions. So that quadratic function, remember, is f of x equals x squared. So make sure we're all writing this down here. What do we know about this function right here? F of x is y. Okay, so I could rewrite this as y equals x squared. Cool. What else do we know about quadratic functions?
The x squared is a v.
Close. X squared is a u. Okay. Cool. That is what I wanted to get there. So our x squared coordinates, these are the u shapes or the parabolas. Let's label that. This is a parabola. Okay, so what we're going to talk about today is vertex form. What we're going to talk about on Monday is standard form. So we're going to start off. Go ahead and make a note of vertex form. Okay. So vertex form is in the form of f of x equals a times x minus h squared plus k. Now I'm going to put an example with this so we're not just looking at letters. Okay, but this is the standard form of that. Vertex form. And then I'm going to put an example with it of what we've seen before. So I'm going to put f of x right below it equals x minus 3 squared plus 2. This is something we've seen before, right? Yes? Okay. So this is in vertex form. The reason it's called vertex form is because we can get the vertex directly from the equation that we're starting with. So remember in chapter 1, we talked about what these values mean here, this minus 3 and plus 2. What is that minus 3 telling me? It's opposite, right? Think opposite. So this tells me I need to go right 3. What is that plus 2 telling me? I need to go up 2. So this here, that gives me what my vertex is. Okay, so our vertex of this point, right 3 would be 3, and up 2 would be 2. I just wrote it as a coordinate. So that would be our vertex. That's why this is called vertex form, because I can pull the vertex directly out of that. Okay, notice up here in our notation, okay, the vertex is known as h, comma, k. Go ahead and label that. The vertex in our standard form up above is in the form of h, k. Okay. Now, with the vertex form, we're going to talk about graphical features. Okay, so with vertex form, there are 5 key features. Now, we've talked about graphical features before. Give me a graphical feature. Think of number 1 that was just on your test. What are the 6 different things we talked about? Domain, range, intercepts, increasing, decreasing. Okay, so some of those 5 key features are going to show up again here. Okay, so one of the 5 key features, the main key feature from vertex form is the vertex. Okay, so one of them is the vertex. Go ahead and write these down. Okay, and I'm going to continue using the example I had up above, and I'm going to write it here. Okay, I'm going to keep using that example. So vertex, remember, we get from HK from the standard form, but in our example, we got 3, 2 for our vertex. Okay. The next key feature, a new part here, it's called the maximum or the minimum. What do you think of when you hear the term maximum and minimum? Biggest and the smallest, exactly. That's exactly what it means. Okay. Again, what did we say these graphs looked like if we have a squared? Look like a U. Go ahead and draw a U off to the side. Okay. It's an upright U because it's positive out in front, right? What would make it negative? Or I just told you. What would make it turn upside down? If there's a negative sign. Okay, so remember that vertex point is right here, that lowest point of the U. That's our vertex. Okay, is this point a maximum point or a minimum point?
Minimum.
Why do you say minimum?
The lowest.
Yeah, it's the lowest, right? So it's the lowest here, so that's why it's our minimum point. And we can use max and min instead of writing out the word minimum, okay? Let's pretend I put a negative in front of here. What would that do?
It would change it. It would make it go upside down.
It would make it go upside down. So now, where's my vertex?
Right there, that's high. That's max.
That's the max point, right? So for example, this one right here, this is a min. This is a max. So it all just depends for maximum and minimum. It just depends where that vertex is on the graph. It's our highest or if it's our lowest. Okay, so at our beginning example before that negative popped up in there, it was our minimum point. Okay? Next one we're going to talk about is axis of symmetry. What does symmetry mean?
It's the same.
What do you mean it's the same?
Like they're lined up.
On both sides, right? Like if I folded something over, it would be the same.
Yeah.
Okay, what does axis mean? Or have you heard the term axis before?
Like the X and the Y axis.
X and Y axis, right? Remember, those are just lines. Okay, those are lines on graphs. Are there other axes other than the X and Y axis?
Yes.
There is, right? Remember on your IXL, you guys were graphing lines that looked like this or this. Okay, we've graphed those also that are off of the X and Y axis. Okay, so axis of symmetry, we want to see where it gets repeated or where I can draw a line and my parabola can fold on itself. Where can I draw that line on this picture here? Can I draw it this way?
No.
No.
Why not?
Because it's going to keep on.
Right, and if I fold it, it's not going to picture itself, right? So where do I have to draw this line at? I have to go down the middle, up and down. Everyone draw that line there. Up and down. If I folded it across that line, okay, it would mirror itself on both sides. Okay, so that there is our axis of symmetry. What point does it go through?
0.
The vertex specifically, right? It goes through the vertex point, okay? And it's a vertical line. Remember we talked about vertical lines? Those are our x values because it's going through an x value. What is the x value of my vertex? Again, here's my vertex. What's the x value of my vertex? 3. So our axis of symmetry would be x equals 3. Yes, you have to write x equals, because if you just told me 3, I wouldn't know what you're talking about. Okay, so you have to tell me x equals 3. Okay, and the last two features are what you're used to. It's domain and range. Okay, domain is always going to be the same because these are always going to have arrows. Okay, so what is the domain always going to be?
Negative and positive.
Yeah, it's the x values, but it's always going to be negative infinity and positive infinity. Domain is always going to be the same for these. Okay,
No matter what.
No matter what. There's always going to be arrows on these.
Okay.
Yep, so whenever we're just talking about the generic quadratic function, you can always think it's going to keep going. Okay, what does range mean?
Y-axis.
Y values, right? Thinking of the y-axis. So again, I draw this picture as a reference here. Remember we said our vertex is a minimum point. So what is my smallest y value if our vertex is our smallest point?
3. 2.
Y value is 2, right? Because I get that from our vertex, so we get 2. And then what's my highest? If I keep going. Infinity. Yep. So, do you agree I could have gotten all 5 of these features just by looking at this?
Yes.
Once I had my vertex, I could, right? What helped us kind of visualize what was happening? The picture, right? I can just draw this picture. It does not have to be perfect on a graph, but we know whether it's opening up or if it's opening down. Okay? Last thing I want to talk about with this, how do we get all of our other points once we have our vertex point? How do we get all of our other points? What'd you say? You could plug in a bunch of values. What was the pattern that we used?
Step back.
Oh,
Step pattern. Yep, step pattern.
Isn't it like 1, 3, 5?
It's our odd numbers. Yep, 1, 3, 5, 7, and then you would keep going if we needed to. Okay, this is our original step pattern, so that stays the same. Remember, these steps are how much you're going up. Okay, do you think the step pattern is always going to be the same?
No.
In the examples we've seen, it has been the same, right? If I take us back up to what we were looking at before, what else do you notice in our vertex form right here? There's an A. Okay, what does that A mean? We've talked about when that A is negative, what happens?
You have to.
It flips it upside down. Okay, what if that A, what if I came back down? What if I put a 2 in for that A up here?
Does that make those negative numbers then?
If it was negative, yes. Okay, but what do I do to my step pattern if I have a value of A that is greater than 1? What do you think I do with the step?
You got
Go up.
How much?
You go up by 2.
I'm going to change it by a scale of 2. So whatever my a value is, in this case it's 2, I'm going to multiply each step by 2. So then my new steps will be different. So 2 times 1 would give you 2, 6, 10, and 14. So the a, or whatever value is in front of your parentheses there, or your quadratic, that's going to tell you how much the step pattern's changing. That's how much you multiply by. Yep, so if it was a 4, what would you multiply your steps by? 4. Yep. Now, what that does is it either makes your U look like this, and it just makes it wider, or it can make it really skinny. Okay, almost like a V, yes. You can also have, we're not going to see much of these, okay, but you can also have fractions for your a values.
Will the U ever get so narrowed as just like a straight line?
It very well could be, depending on what the a value is, yes. So like if we were on like a graphing calculator, we could zoom in order to see what's actually happening. Yep. So on example 1b, I know they gave you a graph there, but we're not going to graph it. Okay, we're not going to graph it. So here I'm just going to rewrite it for a reference. We have g of x equals 3 times x minus 1 squared plus 2. I want you to tell me what the 5 different features are. So what was the first thing that we talked about? Vertex. That's the most important part. Where do we get the vertex from? Go for it. Yeah, we see where what's happening. What's that minus 1 telling me? We got to go right 1. What about the plus 2? Up 2. Now I want to write that as a coordinate. If I'm going right 1, we want that to be the x, right? That's going to be a positive 1 to go right 1. And then what about up 2? Positive 2. Yep. So there's my vertex point. Make sure you're writing these notes down, please. What came after the vertex? What was our next key feature? Max and min. Yep, and again, you can do max and min instead of, you can abbreviate. What can help us understand max and min? Yeah, you can draw a parabola. Does it have to be perfect? No, just draw U. And how do I know it's opening up? How do I know my parabola is opening up and not opening down? Right, it depends on whatever sign's in front. Okay, so I know it's opening up. How do we base the max and min? The vertex. Yep, so here's my vertex. Is that a maximum point or a minimum point? It is a minimum because it is the smallest point on the graph. Okay, so that's our minimum. What was after max and min? Axis of symmetry. Here's a notation for that. Capital A, little subscript O, capital S. Axis of symmetry. Okay. Where do we get the axis of symmetry from? Or what does the axis of symmetry do?
Because it's the point.
Yes. What does symmetry do? What's happening?
They align. Like when you fold, it's the same.
If you fold it, it's the same, right? So remember we talked about this line. Yes? Okay. What value do we want from the vertex for that axis of symmetry? What'd you say? Want the x value, right? So it's x equals, well, what's the x value? 1. Yep, let me stay with colors. We get x equals 1. Can I just put 1? No, I have to know exactly where that line would be on the graph. Okay. And then what were my last two? Domain and range. What is the domain always going to be? Yep, flip that though. There you go. Negative infinity to positive infinity. Now the range, this might help looking at the picture again. Okay, so with the y values, what is my smallest point on the graph?
1, negative 1.
What's my smallest point on my graph right now? It's the vertex, right? So our vertex, our smallest point is 1, 2. What is my y value to that point? 2. And then what's my highest y value on the graph? Positive infinity. Good. Okay. We're not graphing it, but I do want to talk about it. If we would graph it, our step pattern. Yeah, our original step pattern is 1, 3, 5, 7. Why did you say we have to multiply by 3? Whatever that a value is, right? So I'm going to multiply all of these by 3. So we get 3, 9, 15, 21. And then you would be able to graph that like normal. Okay, and remember the step pattern is how much you're going up. Okay? example 2, it gives us that function. I'll rewrite as a reference. F of x equals negative x plus 4 squared minus 5. What's the most important thing we need to figure out to know everything else? Vertex. Okay. Where do I get that from? Yep, here. What is that plus 4 telling me? I need to go left 4, minus 5, down 5. So our vertex is negative 4, negative 5. What do you notice every time we put for our x value of our vertex, the difference? Have you noticed something? Whatever the sign is here, it's going to be the opposite sign here. Okay, every time. Okay, and then the y, that one's always going to stay the same. Okay, so you can use that little trick to help you. What was after vertex? Max and min. What's going to help us visualize max and min? Yep, so what does my parabola look like?
An upside down here.
Because
Because it's a negative.
Yep, negative, so we got to go upside down. Is that vertex a max or a min? That's a max point because it's the highest point on the graph. What came after max and min? Axis of symmetry. Again, what does the axis of symmetry do? It has to be x equals, good. What does it do to the picture?
Make sure it's like biblically flipping side.
Yeah, it splits it in half, right? What does that x value equal? Where do we get that from? The vertex. Yep. X equals negative 4. What came after that? Domain. Yep. Is that ever going to change? Nope. And what was after domain? Range. Now this one's a little bit different. Use the picture to help you out. What is my lowest y value?
Negative 5.
Careful. Y.
Because it's the lowest one.
Right, it's going to keep going down, right? So we got negative infinity. Now what's my highest y value point? Where do you get the negative 5 from? The vertex. Notice how everything is coming from the vertex. Do you agree? That's why it's called vertex form. Everything is coming from the vertex. Okay, so again, here are our 5 key features of vertex form. Okay. All right, looking at number 2 on the back page, that error analysis, it shows you this function here, x plus 3 squared, and this person said that means we're going to translate 3 units to the right. What's wrong with that?
It has to be 3 to the left.
It does have to be 3 to the left, okay? Because remember, to get our vertex, we use this as a starting point, so that would tell us left 3. So I know that's a minus 3. Did anything happen with the y's?
No, because there's
No. So what do I put? 0. Same thing if I had this equation. Okay. Did anything happen with the x value? No. Okay. If there was, remember there would be parentheses here. But nothing happened, so what would I put for x? 0. And then what's this plus 3 mean? Up 3. So we'd have 0, 3. Okay. All right, what I want you to do is I want you to do number 5 and 6 on the right side. Okay, just telling me the graphical features. Okay, 5 and 6. So go ahead, do, and we're not going to use any of the rest of that side, so just 5 and 6. Name the 5 key features.